Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast.
Welcome back to the Passive House Podcast. I'm Matthew Cutler-Welsh, coming to you from Tamaki Makaurau, Auckland in New Zealand. And I'm joined this week by Zack. Zack, how you going?
I'm great. How are you?
Pretty good. Just getting over a cold, which I haven't had a cold for a little while, but just getting reminded that it's winter time and there's a lot of sickness going around, which is kind of relevant to what we're going to be talking about today, about viruses and indoor air quality. But we've also got Mary with us. Welcome back, Mary.
Thanks. Nice to be back.
And, I understand that things are relatively clear at the moment, but Zack, you still running that fan in your little office?
I am. And right now, the air quality is pretty good in Seattle, although we are definitely seeing a lot of smoke in the air. So I think it's just the wildfire smoke is high enough that it's not a problem here. And we're seeing the kind of like that beginning period over the last couple of days. So hopefully we won't get walloped.
Yeah.
So far we've been lucky in Seattle this summer.
Well, we'll jump into some more about that. We've actually got a re-release of a previous episode. It's only a short episode, and it's well worth a second listen, because I had a listen to it again and picked up a whole bunch of stuff that I'd either forgotten or hadn't picked up the first time around. So really great to catch up on that. And this issue of indoor air quality and ventilating is only going to get more important. So it's definitely very, very topical. But before we get into that, Zack, we've got a few people to thank.
We do indeed. So I want to start by thanking Icon Windows and Doors. Icon Windows and Doors is our sponsor of the week at Passive House Accelerator. So they're making the programming that we have going on this week possible. So big thank you to Icon. Also, thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050.
Cool. And we also, as you know, we're in the middle of doing our cooling and resilience, building resilience series, little mini series here with that focus, and we're really keen to hear people's stories. We've got Zack, you want to give us the details about how people can?
Yeah, absolutely. So we're gathering stories from you, the listener. So and there's a link in show notes to a place called SpeakPipe, where you can go and record a short voicemail, essentially, that we will then consider including in the episode, where we're going to have a bunch of cool DIY stories from the community. So if you've MacGyvered a solution for cooling or summer resilience, you have a DIY solution that you can share with us, please go to that link in the show notes and record your story. We look forward to it.
And I think that is how this topic kind of got started, with people DIYing their own solution for filtering or scrubbing the air inside their homes, particularly, both during COVID, but also during some quite large wildfire events that meant that large areas had very high rates of pollution, very high particulates in the ambient air, and people were doing, figuring out ways of of dealing with that, because air conditioning or just a fan aren't going to help with scrubbing the air. So that's the backstory of the Corsi. I always get this wrong, Zach.
The Corsi-Rosenthal cube. It's also known as the Comparetto cube. Yeah. All sorts of folks involved in helping to put together the solution.
And we will share some links. There are plenty of photos and also videos of people putting these together, ranging from cardboard, which John talks about on this interview, and I'm guessing that other people have got more fancy laser cutting and who knows, 3D printers. I'd love to hear from you. Get onto that speak pipe if you've got a solution that you've put together or know of. We'd love to hear from you about that. But let's jump into this interview. Like I said, it is a re-release, but very worthwhile, and I hope you pick up something again from it like I did.
Well, John, as I've been reading the headlines around the wildfire smoke events that are impacting the East Coast, I've been thinking about you because you're the sort of the go-to guy in our community around indoor air quality, and you also have helped us with moderating and informing some conversations around wildfire smoke and indoor air quality. So it's great to have this conversation with you. Thank you for taking some time.
Oh, thanks, Zach. I'm happy to chat about it. It's too bad that the East Coasters are now experiencing this, but I think it's kind of going to be, at least in North America, it seems like it's going to be a near universal problem here and there.
Yeah, right. So how do we become resilient to it? Yeah. And you've done, among others, there's this community that's grown up around kind of trying to answer that question, both in sort of short-term immediate ways, the triage approach, and then also the longer-term structural ways that we can make our buildings more resilient to these events. So I was hoping that we could touch on both, and we could start with, the short-term immediate way to improve indoor air quality during these severe outdoor air pollution events, and to touch on the Corsi-Rosenthal Comparetto cube box, if you wouldn't mind. What is that?
The most popular name is the Corsi-Rosenthal Box. There were, in the early days, some people were calling it, for fun, the Comparetto Cube, which was named after my business partner, Neil Comparetto. We were among the folks who were really involved early on in testing out this idea for this do-it-yourself DIY fan filter box. So different names caught on, but I think the Corsi-Rosenthal Box is what most people know it by. So it is a box fan. So this is like a 20-inch by 20-inch utility fan that is pretty ubiquitous in North America, at least. Many households have one or more of these fans already in their household, or you can go to your local hardware store and pick one up for $25 or $30. So it's a box fan that sits on top of 4 filters. So 4 high-performance filters, typically MERV 13 filters is what we're using. And you tape the filters together, and then you tape them to the fan. And so the air flows through the filter and then out the fan. So what that gives you is a whole bunch of airflow, because the box fans are relatively powerful, moving through pretty high-performance filters. And you get really great reductions in fine particles.
Right. And those fine particles, as we know, are with wildfire smoke, are extremely hazardous to our health.
Right.
So, and this is an exciting way that you can take action right away during these. I mean, these are pretty scary events, and we see these orange skies and things, and realize that our houses are becoming not safe to be in, even though they're a little bit better than being outside. So this is an action you can take right away, which is which is awesome, and they're also not that expensive. Assuming you can source the stuff.
Yeah, and fortunately, at least right now on the East Coast, we've had a mild late spring so far. So folks who don't have air conditioners have not had a big reason to go out to buy fans for cooling. So I just went out and bought a fan at our local big box store. They had 150 fans in stock at the moment. So they had a good selection, and they had lots of filters. So of course you need the filters, you need the fans, and then you got some cloth tape. So those are the three components. And then the cardboard, you can cut up the cardboard from the box that the fan comes in and use that for your base, or to build a little shroud over the fan to improve airflow. Folks will be able to see that in some of the videos or pictorial tutorials that we can include that show kind of how to put one of these together. It takes about 20 minutes, and if your DIY skills are up to the scissors and duct tape level, which I think is just about everybody, if you're up to that level, you can build one of these in about 30 minutes. Yep.
So you can imagine you close up your house so that there's no more smoke coming into the windows, for example, and you're running this thing full blast, is 24/7 to scrub the air essentially.
Yep.
So what it doesn't address is bringing in fresh air, like basically when you're filtering your air inside, you're still getting a buildup of CO2 as the occupants inside are exhaling CO2.
Right.
So if you open the windows, it means there's more smoke that needs to be filtered out by this device.
Yep. Exactly.
So there are some limitations to this triage approach.
Yeah. So this fan is filtering fine particles. It also is going to filter. As a little side note, this whole kind of DIY project got started because of COVID. So it filters out viruses as well, because viruses are mostly attached to fine particles. But it's not going to get rid of CO2. It's not going to get rid of VOCs either. So you're still going to get, odors from outside, other, chemicals from outside or from inside if you're generating them from cooking, for instance, or you have other indoor sources of pollution. This filter fan isn't going to capture those unless those things are attached to particles.
Right. Yeah. So let's then pivot to the longer term kind of structural solution in our buildings. What could you describe the key elements to that kind of building integrated approach to indoor air quality?
So I think if we were starting from scratch with a new build or a big retrofit, what we would really want in order to have better control over our indoor air quality is an airtight enclosure and then a ventilation system. But on the ventilation system, of course, you would want very high performance filtration, or at least the ability to swap in very high performance filtration, which I know some folks have done on the West Coast during these kinds of events. So super airtight, passive house levels of air tightness, or even better, as many of the practitioners have discovered that they can achieve, and then balanced ventilation with from an energy standpoint, you can still do energy recovery, heat recovery with your ERV or HRV, but on that outdoor air intake duct, you need very high performance filtration. And the kind of modeling and the real world practitioners' experience so far, especially practitioners who've been through multiple wildfire seasons on the West Coast, other practitioners in Australia as well, they've really found that you need MERV 16 to HEPA levels of filtration on that outdoor air duct, unless you want to do additional filtration indoors. So if you want your ERV, your outdoor air filter, to do everything for you in that airtight structure. You need that, top of the line filter available, and that's for most ERV and HRV systems. That really requires a dedicated pre-filter box. Most of the manufacturers do. I don't think any of them have that level of filtration available. I might be mistaken, but I think you really need something that's going to take care of that before it hits the ERV.
Right. So it's not kind of standard issue for an HRV or ERV to have that level of filtration. And also there's for VOCs and the odors from wildfire smoke, carbon filters are helpful as well, right?
So you can VOCs and odors, carbon, or some people call it charcoal filtration is as far as I understand, the best way to do that. And you need a decent mass of that material in order to capture a significant amount of those chemicals. It's not just a little coating on a filter is going to have a short-term impact. If you want long-term VOC removal, long-term odor removal from that outdoor air, you need like pellets of charcoal, pellets of carbon that the air is flowing over to remove those chemicals.
Right. So for passive house owners or occupants, who are maybe dealing with this kind of wildfire smoke event for the first time, they are probably noticing that their indoor air quality levels are not great. They're probably significantly better, perhaps significantly better than a typical house. There's certainly a good foundation because they've got the airtight system. They have a filtration system or a ventilation system that allows them to filter. But really, they need to take this extra step in order to deal with the wildfire smoke of having MERV 16 or HEPA level and potentially carbon.
Yeah, exactly. Many of the owners are going to have ERVs and HRVs with, MERV 8, maybe MERV 11, maybe MERV 13 filters as standard issue from the factory. And those are experiences that, those just aren't good enough to hit the indoor air quality levels that we'd really like to see for healthy living.
Right.
And so they're definitely going to need to bump those up, and likely that's going to have to be with a separate add-on filter box. That'll have to be retrofitted. So that's something in my own house. My ERV has MERV 8 filters, which are fine. They do well, day to day in Central Virginia. Most of the time, we had a wildfire in the Shenandoah National Forest in 2016. So it wasn't nearly. It was actually much closer to us, but not nearly as bad from an outdoor pollution standpoint as the impact of these fires from Canada. But now, I'm thinking that in the long run, I'm going to need to retrofit a pre-filter box.
Well, that's a great segue because it was yesterday or today that you kind of made a combination of you have the structure, the foundation of the structural long-term approach, because you've got good air tightness, you've got a filtration system, a ventilation system, but you just added the triage piece because you don't yet have that extra filtration,
exactly right?
Yep. Yeah. And so can you walk us through the numbers of what's been going on outside in terms of the PM 2.5 and what's been happening inside your house over the last couple of days?
So at my house, on my porch, I measured with a home sensor. I measured around 170 micrograms per cubic meter, and at the same time, indoors was 60. And we really want, for really good indoor air quality, we want that to be under 5. The WHO guideline is 10 or less. But really, there's the lower the better. There is no such thing as getting too low on fine particles.
Right.
So the lower the better. So I was at 60 earlier. So I actually went out this afternoon I already had a HEPA air cleaner that I had purchased very early on during COVID. And so I'd never built one of these Corsi-Rosenthal boxes for my own household until today. So I went out and picked up a fan that we already had filters at the shop and built the box in about 20 minutes and turned it on. And I turned off the HEPA air cleaner just because I wanted to see the difference if there was one. And the DIY box actually does a much better job of removing particles, it's a little bit non-intuitive because we're using lower performance filters, but we're moving like 5 or more times the air. So the net performance is all about the airflow, how much airflow, how good is the filter, and then to a lesser extent, are you getting any kind of filter bypass or thing? Are you getting good distribution of the air within the space?
I have 2 of those same model, I think, HEPA filters that you have, and so after this story, I am now inspired to build myself a cube. I have the DIY skills that necessary, so I'm excited about that.
Yeah, and there's some some folks, obviously $75 is a great price point. Some folks are willing for aesthetics to do some additional modifications, some additional enclosures, especially folks who have laser cutters and things like that.
Fancy.
You can make some fancy enclosures for your DIY fan filter box and make them look, as good or maybe better than some of the HEPA cleaners. You can't get around them being big. So they are going to be big. And that's really important, is that you have a big surface area of total filter media. So just, a lot of surface area for the air to flow through. So it's low resistance. So it's easy for the air to flow through the filter. And then you have a powerful fan to move the air through the filter. Those are the 2 key things.
Okay. I'll remember that as I'm building. Thank you. Well, John, I really appreciate your time. Thank you. And I know that folks will be really happy to get some guidance on how to deal with this wildfire smoke. And we'll be probably referring to this video more times than we'd like in the future as we are dealing with these events more and more.
Right. Yeah. And there's, especially on the West Coast, the passive house practitioners and the passive house owners who have been through this, they have a lot of experience at this point with kind of what's working. They probably have some good experience with these kind of retrofits as well. So it'd be good to do a follow-up with some of them to see, okay, we talked about, some of the triage stuff that you were doing a few years ago. What have you done structurally, since then? What's working? And maybe we'll even see some kind of prepackaged products that are kind of, ready to go and really geared towards the typical airflow rates that we see for ventilation systems for passive houses, in that 75 cubic meters to 150 cubic meters, some sweet spot, pre-filter designs that are ready to go and fit into the folks' mechanical rooms and basements and crawl spaces.
Yeah, exactly.
And that was John Semmelhack talking about how to build a box fan filter or a Corsi-Rosenthal box or various other names. Now, Mary, we've got you on the call here. You've actually got your own integrated ventilation system. Tell us a bit about what you've got and what options you have for increasing the filtration on it.
So we have an HRV system in our house, Zender, and we, when there was a few years back, really bad smoke events here. Fortunately, we haven't really had too many since then, but prompted by that, we got a FanTech inline filter box that you can that we installed before HRV. And so when there's a smoke event or some other reason that we might want to really increase the filtration in our house, you can add the filters. You don't want to have the filters in without having a supplemental fan going, because otherwise it just creates too much of a pressure drop through the filters. So you need that supplemental fan to push the air through and not interfere with the supply to the HRV. Fortunately, I have never had to use it, so there's no, I can't tell you what it's like, but yeah, we have avoided smoke events so far.
Is it something that you just slide into the duct, or is there like a compartment for it in the heat exchange unit? Where do you actually put the other filter?
Well, the Fan Tech is a box that you just slide the filter into. Yes, it just has a slot that you slide the filter into when you want to use it.
And it's installed into the ducting system for the intake air, right?
Exactly. Yes.
Yeah. So there needs. I mean, one consideration is you need to have space to do that, because they're fairly bulky. I mean, I think that's one thing that John mentioned, that just there needs to be enough kind of mass with the charcoal to be able to be effective.
Right.
You actually, Mary, is yours a charcoal filter, or
No.
is it just no? So that's right, because the charcoal filter, my understanding is to filter out the smell of the wildfire smoke smell, and the pre-filter that you have is more just about filtering out the particles. Right.
It's a HEPA filter.
Yeah.
Yes.
Yeah.
Zach, one of the other things that you talked about in the interview was the kind of decision you've almost got to make about whether you're going to have clean air or fresh air, or oxygen, because in they're relatively extreme. They are smoke events, as you described them, Mary. You are sealing the house up. You're closing the windows. You're shutting down what's coming in, and I guess you've experienced that also in some ways with your fan that we sometimes give you a hard time about, that's sitting there
right in my office,
quite noisily.
my stupid office.
Yeah. I mean that's moving air. It's doing part of what you need for comfort, but it's also not necessarily. Yeah, you're sort of building up the CO2 at the same time and not getting any fresh air. So I guess that's part of the problem of not having a solution like Mary has, which is a ducted system that is bringing in air and is still bringing in oxygen, removing CO2. But for short periods of time, that's part of the compromise, I guess, is that you have to decide, well, I don't want these particulates because they're really, really bad. I'm going to sacrifice slightly higher levels of CO2 for that period of time.
Yeah, exactly. I mean, I think that Mary and we're kind of like the two different case studies, right? Because Mary has the passive house, so she's got the structural solution in place, and I'm very envious. We have not yet retrofitted our house to passive house, and so we have a more conventional kind of issue, and so yes, we have trade-offs for sure, and we need to, in order for that filter box, which I have built and now have in our house. We used it last summer. We haven't had to use it this summer yet, but that when we decide to use that we have to close up all the windows and doors. Still, we can't. It's not, if we're bringing in a whole bunch more smoke all the time with open windows and doors, then the filter box can't do its job.
Yeah.
So I think that it is really great though to at least be able to filter the air inside, and because I mean when we're exposed to these conditions with the wildfire smoke, it's the equivalent of smoking packs and packs of cigarettes.
Yeah.
And we're also, not only is that a problem for us adults, but I just hate thinking about that, exposing our children to that or kids.
Yeah.
But if it's hot and in Seattle, we don't have air conditioning in most houses. We do not have air conditioning. Then we rely on night cooling, flushing the with night cooling with open windows and throughout the summer. And during a wildfire smoke event, we can't do that. So the combination of a heat wave and wildfire smoke and our house is not a good one.
Yeah.
So the triage solution is really a great kind of short-term solution for sure. But our buildings, conventional buildings in Seattle, are not built or prepared for what we are now experiencing. So it's just a initial step for sure.
You mentioned the difference between your house and the challenge of retrofitting. One of the big takeaways I remember from doing passive house training was around the ventilation and this idea that you start with the envelope, you sort of make the thing airtight, and that's what John mentioned there. It's the first benefit of passive house is you're not going to get infiltration, so air and therefore smoke and stuff leaking in through uncontrolled cracks. But the next thing is to put the ventilation, figure out where you're going to put the ventilation, and good design, as I was taught, was kind of figuring that out first, your plant room, and then almost designing the house around the ventilation system. And that's why retrofitting these systems is so challenging, because if there isn't a dedicated space for a heat exchanger and then places for the ducting to go and reasonable layout of the house so you don't have really long duct lengths, particularly to get the entry air and exit air, that's really, really challenging. I'm seeing this now with some designs, apartment buildings, which were designed not knowing that they would need continuous mechanical ventilation, and that they're having to sort of go to great lengths, literally, with these ducts going crazy places and trying to find a spare cupboard space somewhere. Whereas if you do that from the start, you can really fit that system in. And that was a bit of a penny drop moment for me, realising that the core of getting a passive house done cost effectively and well is really about figuring out that ventilation system as one of the priorities, and then designing the rest of the house around it. Obviously, that's easy when you're building new. You've got a blank sheet of paper. Very hard to do when you're retrofitting. And then, of course, if you're dealing with an emergency situation, which is what we're talking about now, is you just got to get those particulates out of the air, because, like you say, no one wants to be sucking in that stuff. And finally, on that point, I think it's worth us remembering that a lot of people might not realise that a heat pump is not ventilation. And this is a constant thing that I come up with, that people assume that because there's this, especially mini splits, there's this thing on the wall inside and it moves air, and there's a thing outside with a big fan on it. It's a very reasonable assumption that it's moving air from one place to the other. It's not. It's only moving refrigerant in between those two units. And that's, I think, we really need to remind people that thing on the wall that makes you either cool or warm does not bring in fresh air. Anything else to finish off? Mary, you got any closing thoughts?
Well, yeah, and unfortunately for me, although I can have filtered air, with summertime resiliency, I can't do what Zach was just talking about during smoke events and night flush my house, which is how I keep cool here too. So that's, a compromise that you have to deal with. Good news for retrofits is that there are newer options, all-in-one ventilation with a little bit of heating and cooling, that are out there since we did this, even, since a year ago. So, that's great that those retrofit options are growing.
There seem to be a increasing range of options of air purifiers, the ventilation systems, a lot more awareness and a lot more industry knowledge about all of this, which is really, really great, very encouraging. Very keen to hear people's own stories about what they've installed on their system. on their house, whether that's something that you've created yourself or something that you've installed in an existing system. Zach, you want to give us those details again of the speak pipe?
Well, check out the link in the show notes to get to the right page on SpeakPipe and share your story. I will say that for folks who haven't done one of these cubes and have a need for that kind of triage solution, and it works, as John mentioned, it works if you have a passive house and you don't have a pre-filter box. It's a good tool for that. It also works great for for these emergency situations in conventional houses. They're really easy to make, and mine is cardboard. I did not do any laser cutting, and you just cut. The cardboard you cut from the box of the fan, and then it's just tape and a little bit of care and a few filters. So definitely highly recommend putting it together, and it's fun you can do it with your kids. It's a fun little project.
Fun project. So use that SpeakPipe. Tell us all about what you've done or what challenges you faced, and how the air quality is in your region. We'd love to hear from you. Or if you've got any other questions that you'd like answered, we're going to do a bit of a wrap up at the end of this cooling and resilience series. All right. Well, I think that's about us for this week. Unless we've got any other announcements, Zach?
No, I think that's it. Thanks.
Awesome. Hey, well, thank you. Thanks for joining us, Mary. Thanks for this re-release of a very important topic. And we'll be back again next week on Passive House Podcast.